All right, so we're headed back into the test, or done with the test. We'll have those graded and back. You'll be able to see me during office hours. We can also talk about it during the next class. So moving on, let's see if I can figure out how to share my screen again. All right, so what we're covering now, we're talking about traverses. All right, we've got some of the basics down. We've gone over the linear measurements, the horizontal measurements, the vertical measurements. How do we put it all together? We did the trig review. You started with some of the labs, started your experiences there. So how have the labs been going? How are you guys doing on those? Going all right? Hello? Okay, pretty good. Thank you. All right. So any questions on those? You've got Kyle here. I know you guys are going to pick back up at 9 o'clock. But for the next hour and a half, we're going to go over some of the details behind it all.
We do not have a 9 o'clock thing this evening because the lab is the 10th. So I just wanted to make an announcement that the schedule was slightly changed. Sarah and I coordinated our schedules about what was getting covered this week and next. So we will be doing labs 3 and 4 on the 10th rather than the 7th.
Okay. All right. So now is your chance if you have any questions for Kyle. Okay. So traverses. It's a series of connected measurements, connected line segments, right? As we go out, we start having these turning points. We pivot around certain locations. They can be closed loops where we come back to the beginning, and that's what some of the homework showed when we did those leveling examples. They can also be open. We might be traveling a straight line. I'm putting straight in quotes there. You know, we might need to follow a path of some sort. So all right. Come on. So today we're going to talk about horizontal angles. We're still dealing in flat surfaces, right? Gets a little confusing because we say we're dealing in flat surfaces, but really we're just looking at an entire plane, whether it's oriented horizontally or at an angle. We're starting to bring those measurements in if we have an angular measurement, but for the time being, we're still talking about angles, relatively dealing with flat planes, right? So 5 basic kinds of angles that we're going to talk about. Exterior angles, so that's anything that's measured on the outside of our closed traverse. Interior angles, anything that's on the inside of our traverse. An angle to the right. So I might look backwards to you, but hold up your right hand, angle it towards the right, that's an angle to the right. So that's what these deflection angles are showing down below. And this angle at C. So we back sight on B, and we swing our angle around to look at D, we're swinging it to the right. You can also swing to the left if that's okay. And deflection angle. What is the angle off of our existing line? Okay, so we may not, our line might stop here in these deflection angles at point B, but we can hypothetically extend that out to help with our measurements. So we would project that along that line. Okay. All right. From your lab, exactly what I just said. From C, we're looking back at B, we're taking a foresight to ensure that we're measuring our angles and closing our traverse. We turn our angle back to the right. So these are some of the practical applications that we'll end up having for that. Why is that not going? All right, so what information do we need to describe an angle? Jump on in. All right. So
there was something in chat. Slope
okay,
is
so
one.
slope, not so much, right?
Ah,
We just finished that section on the angles, on the slopes and a vertical angle. Now we're talking about horizontal angles. So how do I define that in time and space, right? So how big the angle is, right? We need the numerical value of the angle, okay? What else would we need? Am I starting here? Am I starting here? Am I starting here? Or do I start here? What is my reference point? Kenny, that's absolutely correct. What direction, right? What else might I need? So I got my direction, whichever way that is. What about where I am now? I need to know where I am in time and space in order to define those other components, right? This is killing me tonight. So we need our point of reference and we need a direction. We need to know what we're doing, right? My space bar is not working. So how do we define those directions? Two of the most commonly used pieces of nomenclature, two of the most commonly used ways of describing a horizontal angle, azimuths and bearings. So because I like to go alphabetically, we're going to start by talking about azimuths. How many degrees in a circle? Well,
360.
360. But as you will see in the reading, there are other methods of measuring a circle.
Oh, that's interesting, actually. Oh.
Okay. There are some methodologies that use 400 as a base. Radians is a different measurement as well. So when we talk about azimuths, we talk about a 360-degree compass, basically, right? We have our point of reference and our direction. We have a north-south bearing or median line, right? That's going to be our reference. From there, we measure clockwise as we go around that circle until we come back to true north. And I for the time being, I'm using some terms kind of loosely, right? We're saying we're coming back to north, straight up. We get into too deep in terms of magnetic north, et cetera, right? We'll touch on that in a little bit. But with an azimuth, it is always assumed that you are pointed north, okay? Your measurement will always be taken clockwise to the right, and the numerical value of that angle would be anywhere between 0 and 360, okay? So line 1, we say the azimuth is 45 degrees. So what would we say line 2 is? A little bit of math.
180 plus 15. 195.
Yep. 195, absolutely. Okay, so that's the azimuth. Now, the next one is bearings. Same exact diagram, but it is based off the north-south line. So we might measure from the north to the right. We might measure from the north to the left. So now we start using quadrants. We're going to use compass bearings. Okay. So our reference points are north and south. Our directions are going to be based on east and west. Our values will be anywhere between 0 and 90 degrees. All right. So if I have an angle and I'm starting from true north, from straight north, and I go 95 degrees to the right, where does that put me? Now I'm facing east, but since I'm over that 90-degree mark, now I'm really in that southeast quadrant. I'm down in this area here. So that's one of the things that we're going to watch out for is where does that put me? Right? Where does my angular measurement take me and what direction am I facing? All right. So if I had to create a bearing for line number 1, I'm north, I'm 45 degrees towards the east. So my line 1 is going to be north 45 east. So what about line 2?
South 15 west.
Absolutely. Very good. Yep, south 15 west. Okay. 15 degrees off of that north-south line in the southern area towards the west. Okay. It's kind of like the joke. I always like seeing it. It's a little meme that comes around Facebook all the time. It says, when I ask for directions, don't use words like north or east. Tell me if I need to turn left or right at the stop sign. And those of you that have grown up in the Santa Cruz Bay area, or actually it's the Monterey Bay area, but who have grown up in the area, let me tell you that growing up on the north side of a bay will really screw up your sense of direction because the ocean is to the south if you're standing in Santa Cruz. It really confuses you. I use that as an excuse all the time. So when we're talking about bearings and azimuths, 2 different graphical systems that you can think of. I like this image a lot. Azimuths, it's all about degrees. It's how far around the circle are you going, okay? Bearings, what quadrant am I in? I need to know which direction I'm going before I can figure out where my line is, where my line of sight is supposed to be. Okay. And questions on that so far? All right, pretty straightforward. We're going to do a lot of practice tonight. We're going to walk through a lot of examples. All right, so for example, we will be doing conversions. This gray hair that's killing me here. All right, so for the first one, if we have an azimuth of 32 degrees, 5 minutes, what would be our bearing? Okay. Azimuths always start measuring north and going clockwise. So if we look at that, we're north, we start going clockwise, that puts us up here in this quadrant, which is our northeast quadrant, right? Since we haven't passed that 90-degree mark here, we haven't passed due east, we can say that we are at north 32 degrees, 5 minutes east. Okay. How about the next one? Okay. Always start with the north-south designation first. Am I facing forward? Am I facing backwards? Then we'll talk left and right. Okay, so very, very nice. Just flip those around. It is south something east. Like I said, it's all about the math at this point. Okay, so my bit of advice while you guys are crunching those numbers on your calculators and converting that into something that we can actually subtract from 180. Anytime you're dealing with a problem like this, and you'll see it throughout the rest of the evening, my recommendation, just start converting into decimals. Get rid of the minutes and seconds, make sure you've got those conversions correctly, and start dealing with decimals. Much easier than trying to add and subtract seconds, then minutes, and then degrees, okay? I'm jumping in. Somebody want to tell me how to convert this? Hello?
What do you mean by convert this? Converting the degrees, minutes, seconds to whatever it is?
I would say that should be our starting point for
Right.
this.
Mhm.
So yeah, let's begin at the beginning. All right, what do we need? What do we need to do? What would be the process for this?
All right. So
How would we find this out? So we say we're at 129 degrees. That puts us down here in this corner, right? So this is 135 degrees. South 45 east is equal to 135. So we're somewhere in between here and here, right?
Right.
So how do we measure bearings? Bearings are measured off the north-south in that particular quadrant. So it would be whatever this angle is going back to our point here. So we know our quadrant. Excellent. Thank you, Olga. Atson, nice. Kenny, good job. Yes, Kenny, you're on the third one. We're still on the second one.
Right.
Okay, so what we want to do is, the reason I'm saying we're converting that is just so we can do the math and subtract from 180.
Right. That makes sense. And that's why I just got a little confused. So
No,
okay.
that's okay. That's okay. This is a new topic, new conversation. So I think everybody's brains are a little bit fried. That's why we're going to hit this one so long and tedious. We're just going to keep repeating it and practicing this. Everybody's brain is probably fried from the exam. All right. So we figured out what quadrant we're in. So now we know we're subtracting from our 180. And when we do that, we get 50 degrees, 42 minutes, and 35 seconds. Exactly what Olga posted. Thank you. All right. So as you've noticed, we're kind of going around the circle clockwise. Our next azimuth is 237 degrees, 48 minutes. Where do you want to start? Walk me through. What would we do first? What quadrant are we in? Okay. Third quadrant. So we're in the southwest corner.
Would you subtract from 270?
270 is our horizontal. We want to measure off of our north-south. So I would want to find this angle here between my south line. Oops. Oh, there you go. Keep my finger off the mouse button. Okay. So what we want to do is we want to figure out what that angle is off of the south facing line, right? So we have 237 degrees, 48 minutes. Let's just say 237 degrees. Okay. What we want to do is back that off of our north line. Okay, so we can figure out what this angle in between will be. We can subtract 180 from that as well. So if I take my 237, take 180 off of that, we're at 57 degrees. Okay, I'm just rounding here, but we'd still have that 48 minutes. So we always want to measure off of that straight north-south line. I always want to say vertical, but it really isn't. It's just north-south, right? It's where are you facing at that moment? So let's look at 295. What quadrant does that put us in?
It'll be in the northwest quadrant.
Correct. All right, north 65 west. Absolutely. Okay. That's exactly where it puts us. Can even put the math in the chat. All right, so we're going to back off of the straight north line and figure out what that angle is between our line and the north line. So that's why we stop when we get to east and west and going outward, because we're measuring off of that north line. When we're down below, we stop at east and west again, because we're still just measuring off of that line until we get to due east and due west. Okay. Guess what we're going to do next? Yeah, question?
Are they used like in different situations when each of them are used, or do we like get to choose which one is more convenient usually?
You know, I don't have a really good answer for that. I'm used to seeing bearings mostly defined by north-south, because it gives you a really good sense of direction in terms of, but again, you have to know which way is north and which way is south, which way are you facing and which way are you headed. Good question. Let me see if I can come up with something. See if I can find an answer for you. Okay. All right, converting bearings to azimuths. Same thing, just in reverse. Okay. So pretty similar, moving around the circle, moving around our range of motion here. So if we're north 37 degrees, 15 minutes east, what's our azimuth? Oops. Correct. Yeah, it's just a reporting of degrees. Okay, it's just a reporting of that angle, whatever it is. Okay, so up in that first quadrant, that's keeping things pretty simple for us, right? Up until 90 degrees. Once we get a bearing that's outside of that initial 90, then we've got to start doing a little bit more math. So let's look at the second one, for example. 37 degrees, 15 minutes. The second one, we're down in that southeast quadrant, but we're measuring off that south line. So when we measure that way, we're actually measuring back towards the east, right? So our angle in here, right in here, you know, see my thumbs? Can't fill it in very well without breaking my angles. This is 51 degrees, 32 minutes. So what's my azimuth? From north, going clockwise. Okay. Atson, double check yours. Double check your math. Okay, so we're going to take 180 degrees and subtract out this 51.32, right? Yep, 90 degrees plus that difference. Nice. All right. That is correct. 128 degrees, 28 minutes. Okay. Come on. Oh, my keyboard decided to quit. This is fun. Oh, okay. Sorry. Whoops. Othello, do you want to tell us what you did? Maybe we can help you get on the right path.
Yeah. What I ended up doing was I subtracted 180 by the 51.32, but I see that. Yeah.
And that is correct. But
Uh-huh.
it's the minutes that are probably throwing off the
Oh,
number.
right. Yeah, I messed up on my calculation that way. Thank you.
Yeah.
I see. All right, cool.
That's why I seriously recommend get rid of the minutes, convert it into a decimal of degrees. Okay. So next one, we're now in that southwest quadrant. Okay. Kenny, is that? Okay, thank you. All right. It's just, you guys remember, I don't even remember what grade math it was, second, third grade, you have to carry the 1 when you're subtracting. That's what we have to do if we're using minutes or seconds. You have to remember to carry that 1 over, borrow from the next column in order to make that number work out. So we have 180 degrees. Kenny's absolutely right. 180 degrees is actually, it's 179 minutes, 179 degrees and 60 minutes. So if we need to subtract out at that level, we can. Okay. It just makes it a little tougher. It's also 179 degrees, 59 minutes and 60 seconds. So if you want to write it out that way and do the math, that's fine. It's not stuff that I like to do in my head. I have to write it out if I'm going to do that. So what's easiest for me is getting it converted to decimals and doing the math that way. Okay. So I think I saw an answer here. That'd be why my space bar isn't working. 204 degrees, 31 minutes. That is absolutely correct. Okay. Puts us in that lower quadrant. So, Enio, you want to tell us what way did you go about coming up with the 204?
I
What did you do to get there?
added the 24 degrees to 180, and then threw the minutes at the end of that.
Perfect. That's exactly it. Okay. Add it to 180, subtract it from 360. So last one puts us in that northwest quadrant. Okay. 303.46, absolutely. Okay. Does anybody have any questions? Anybody want to see the math on any of this? You want to see what comes next? Okay. All right. So bearings in a traverse. This one, I will be totally honest with you. I did these examples right before class, was working on them this afternoon. This one kicked my ass. All right. This one threw me because of the way the image is drawn. So that's why when we went through the examples from the homework, one of the first homework questions, right? Sketch it out, draw it out. If you can, draw it to scale. Right? How many of you have had experience using scales? Engineer scales, architect scales, anything along those lines. Fishing? You mean like fish scales? Okay. All right. It allows us to shrink and expand whatever we're working on, right? There is no way that I can draw out a 100-foot line unless I reduce it accordingly to fit on my 8.5 by 11-inch piece of paper. So we'll get into scales later, but that's, once you can start sketching these things out, it helps you get a better visual so that the answers start to make a little bit more sense, especially when we're dealing with angles, especially like this one, okay? All right. So the problem is, okay, boat headings in fog. All right. So Kenny, if you're using boat headings in fog, are boat headings azimuths or bearings? Compass headings. Okay. So you would associate the north, south, east, and west. So therefore we'd probably be looking more at a bearing than a straight azimuth. Okay. So let's look at bearings in a traverse, right? This is going to come up a lot. There are examples of property boundaries, and they're usually defined by bearings. So we want to know how far do we go. So we need a length to find a property line, but we also need a bearing off of our north-south because we know those are fixed. We can find that with a compass. We can find it with an app on our phone, right? Golfers have range finders. They can find the distance from that. So those are some of the situations where we would need to find out, based on what we've got, where are we going next? Okay, so we're given a bearing for line segment A to B. North 76 degrees, 36 minutes east. We have a measured angle between line AB and BC. We have another measured angle, okay, but it's from C to B, going left back to C and D, okay? So we've got these two angles. We need to figure out what are the actual bearings so we can describe this to somebody. We need to be able to hand this information off to somebody else, okay? So the way we're going to go about finding this. Extend the lines, right? Then we are simply talking about angles. That's really all it is. We can take away the confusion of, am I north, am I south, for the time being, okay? So what we want to do is we want to project these lines to give us our points of measurement, okay? And then what I've drawn in here is I've drawn my vertical lines, okay? I've given myself some parallel lines. These are north-facing lines, but because they're parallel to each other, that gives me those angular properties from geometry and trigonometry. Two parallel lines, alternate interior, opposite interior angles are equal. Handy dandy little things like that. Might have been kind of a reason that we spent so much time on trig reviews, right? So I know that if I have a line and the bearing is north, 76 degrees, 36 minutes east, I face north, I turn that distance in degrees, I rotate, and there's my line, A to B, okay? So I have that angle off of my straight north. So how do we go about finding B? How do we go about finding what our angle is from north or south when we get to B? So different ways to go about it. You know, I did this, it made sense, and now I have to explain it, and all of a sudden I'm like, wait, what was I doing with that? So my notes didn't seem to save. All right. So we kind of brushed past it, but when we're talking about, why am I blanking on the name? Hang on. Deflection angles. God. Okay. Deflection angles are measured off of any reference point. Okay, so our reference point right now is this line from A to B. We've extended it out so we can calculate this measurement here. Okay. So if this angle here between north and line segment AB is 76.36, then we know that this angle here is as well, right? And we know that this angle in here is. By extending this line out hypothetically, I couldn't find the degree sign and I just got kind of lazy. So I started putting asterisks instead of degrees, right? So if I have a straight line, what's my angular measurement of it? 0, 90, 180, right? So I have 180 degrees along line AB. If I know that from A over to this second line is 119 degrees, 36 minutes, subtracting that from 180 gives me this angle here. Everybody with me? I'm not even sure I'm with me.
Yeah, that does make sense. I can see it.
All right. Well, there's my notes. Okay. Other screen. All right. So from our meridian, meridians are just reference lines. Okay, so we call it our north meridian. At A, our angle is 76 degrees, 36 minutes. All right, our angle at B is 180, subtracting our 119.36. Okay, so our angle from our new north, from the north at B down to this line BC, excuse me, is this angle here, 76.36, plus our calculated angle of 60 degrees, 24 minutes, but it puts us in the southeast quadrant because that's greater than 90 degrees. So then we need to figure out what that is. That angle is back off of our south facing line. Okay. So that's where we get our south 43 degrees east. Okay. All right. So this next one got a little tricky for me. This one's a little bit harder, right? Because what we're given is that exterior angle, right? We're given such a large angle there. Finding that value off of C is a little bit tougher. But what have we learned so far? We know that that angle is now 43 degrees. Our angle between B and C and our south is 43 degrees. So what other angle is 43 degrees? What do we know over here? Atson, do you want to tell me, sorry, southwest of C? South and west. Sorry. Yep. All right, so southeast would be off that direction. Southwest would be that direction. But it's this angle here. Now I'll go ahead and fill that in. Okay. So actually from point C, we are to the north and the west, right? And that's our 43 degree because we've got our two parallel lines. I got to not do that in front of my monitor because then you can't see. All right, we've got our two parallel lines. We have B and C between them. So this angle here is this angle here, opposite interior angles. Okay. So with that information, what else do we know? Okay, it's the angle west of our north. Yep.
That's all we need to know. It's south east 180 minus 43, which is 137. No,
Okay.
sorry.
That's okay.
Never mind. I'll
No, I'm
just shut
telling you,
up. Sorry.
this one confused me because that line, that's not an angle, that scale is off. That is not 218 degrees. So that's the hard part, right? So we know what our angle is between our north meridian at C and back to our line segment BC, right? So opposite angles being equal. First, assume we're measuring. Start by assuming we will measure the bearing for CD from the north meridian. Okay, so this is what I'm getting at here. From our north meridian, what's our angle coming back to D, to CD? All right, so let's assume that we're going to be in that northeast quadrant. All right, we're taking a shot at it and saying, you know, if we just look at this, it's showing us we're kind of northeast, right? Headed off in that direction. However, so that's the angle we're looking for, our measurement off of our north meridian. When we do the math, right? So we say that that angle is going to be 360 degrees, a full circle, minus the 43 degrees and minus the 218 degrees 22 minutes is going to give us that little pie shape there. This little angle with the green mark. Okay. So if we do that math, yep, Kenny, that's correct. 360 minus 43 and 218, 22. Okay. Thank you for doing the math. 98 degrees, 38 minutes. What's wrong with that number if we're talking about bearings?
It's more than 90.
Exactly. Yes, it's greater than 90. So our picture is wrong. We're more than 90 degrees, so that puts us in that southeast quadrant. Okay, so our initial assumption was incorrect. We're further than that. We're further down. Okay, so now we need to find our angle off of our south line. So from our south line backwards, we know what this angle is. That's our 98 degrees, right? So we take our 180, subtract that 98 to get back up to this line from our north-south axis. What do we get? (180 minus 98 degrees, 38 minutes. You can make me do the math. Absolutely. Yes, correct. Elam, thank you. South, 81 degrees, 22 minutes east. From the south, go over 28 degrees or 81 degrees, 22 minutes towards the east. So that picture is pretty deceiving. It doesn't give us quite what we were looking for. Maybe the image is just slightly rotated when we pasted it into the textbook. Who knows? Okay. Without measuring out those angles for sure, we just know what we're given. All right. Any questions on that one? Okay. It's all about the angles. Okay. We're just looking at horizontal surfaces. Okay. No, Mason, it's not north. That's the problem, is we've got this vertical line, but when we calculated this angle here, it was greater than 90 degrees, which then puts us in that southern quadrant. Okay. So south, correct. As soon as we drop below that horizontal, we're in the southern nomenclature. Does that help? Okay, good, good. Thank you, Kyle. Yes, geometry is good reasoning about bad drawings. Excellent. That's what we have to make sense out of. We're handed a cocktail napkin and told, go build it. You know, we've got to try and interpret what it is from, I'm not going to be disparaging, but we always used to joke about getting plans from architects. And the drawings would be messed up. Wait, you're an architect. That's your job. You're the drawer. You're the artist. Engineers with bad math, typos in terms of what the slopes or the grades needed to be. Stuff happens, right? We've got to be able to troubleshoot that and figure it out, whether we're on the engineering side or the construction side. We've got to get the job built. So we all have to figure out, where are we supposed to be in reality? Drawing is just a drawing. Because I drew a stick figure in a house doesn't mean that's the actual. Okay. So our best interpretation of it. And sometimes it throws you for a loop and you spend an hour trying to figure it out because you've got the wrong number. And that clearly shows that it is up in that northeast quadrant, but it's not. Okay. The drawings can be deceiving. All right, so there's our bearings. That would be our answer that we're looking for. Line segment BC, south 43 east, C to D, south 81 degrees, 22 minutes east. All right, so next up is going to be the interior angles of a traverse. All right, coming back to the beginning, if we're talking about things like property surveys, we always come back to the beginning, right? We need to know that we've closed that loop, that we have bounded the entire area. Okay, so something just popped in my head. Olga, to your question, I'm thinking about, is anybody familiar with Call Before You Dig, the 811, or we call it a USA, Underground Service Alert? USA 811, yes. Yes, PG&E, absolutely. All right, so here's the thing. Before you go out, anybody goes out and digs more than 6 inches down into the ground, we are supposed to call in a utility location request. And there's this service that posts these service agreements, right? These requests out to all the utility companies. Because before I go and dig in the middle of that street, I want to know, is there a high pressure sewer main that I'm going to run into? Because between the words high pressure and sewer, I don't want anything to do with it, right? Is it a gas line, a Kinder Morgan gas line, right? Transporting product. We need to know what's underground. So how do we tell the USA operators which location I want people to come out and tell me if it's safe to dig? Am I going to hit an electrical line down there if I start digging? So I have to be able to tell them what area I'm going to be working in. So how might I do that? One of the ways I can is I can get a reference point. I can find a benchmark. I can say the white mailbox labeled such and such. Okay. I can use that as my reference point, and I can say from that point, something that's not going to move a whole lot. So I don't want to use the cat sitting on the corner. I want to use an actual location. It could be a manhole, even a lid. From this point, go 500 feet north, go 500 feet east, go 800 feet south, 500 feet west, and 300 feet back north to close. That whole area is where I'm going to be digging. I'm going to be grading the area. I'm going to be putting in whatever I want, a new swimming pool. I need to know that I'm not going to run into any underground utilities. So that's where we would want a situation where we would be using these methods, okay, to define a boundary. So Jonathan, Kenny, have you guys called in a USA? Have you ever done something like that? How did you explain what you were working on?
I actually have a lot of experience with USA, starting with the cable companies, doing all the underground locates and everything.
Okay.
And just for your information, Cabrillo College is applying to become a member of the USA so that we get notified when anybody's going to be digging in and around anywhere near campus. Soquel Creek Water District is planning on tearing up Soquel Drive and replacing everything. And we have a lot of utilities that go back and forth across the street. And Verizon and I think it's Sprint were talking about putting in some fiber optics, and they were just going to go for it on our campus until took a good look at our easement, and I said, no, this is an overhead easement, not an underground. So
yeah, Yeah. So it's critical that all of these communities talk to each other, all these companies, right? So that even takes us back to the concept of as-built surveys. What did we actually install and where? So if we don't have an accurate as-built survey, we don't know what's really underground there. So it all comes back to, we have to know furnishings, apparatus, equipment, and where it is. Okay. Worked with a geologist at an engineering firm. And this was great. Huge open field, hundreds of acres. She goes out with the drill rig because they're going to do soil borings. Kyle, you'll love this. So out she goes. I don't think she had USA'd. Maybe she did. Not sure. I don't even remember. It's quite some time ago. Goes out, sets up the drill rig, drills right through a sewer line. Well, hell. Okay. Get that all cleaned up, get backed out. Kyle, what do you mean? Oh, just winged it? We're going to drill here. All right. So drill rig gets up, relocates. That's clearly not the spot. Wouldn't you know it? Second time, found the sewer line right through the middle of it. All right. So that's why it's important to know what's down below, what's underneath. Okay. Fun stuff. Yes. Yes. All right. So here, this example, interior angles of a traverse. If what we have are these property lines, yeah, we could end up with a property line, the boundary that looks like this triangle. All right. So what are our interior angles? Where would we start to figure that out? Okay. All right. First thing I would recommend, get all of those angular measurements and convert them to degrees. Okay. So AB, 13 degrees, 27 minutes, 56 seconds. 13.466 degrees. All right. BC, 21.308 degrees. C to A, back to our close, right? 40.602 degrees. All right, so where do we want to begin? First, let's begin with A. We like to begin at the beginning of things. Our interior angle for A. What I would do is I would break this down into smaller, more manageable components. All right. Draw a little sketch. So I have here from A out to B. That's this line. I have from A towards C, which is this line. So based on those bearings, our measurements off of our north meridian take us 13 degrees and 40 degrees. So if those are my two boundary points, my two boundary lines, how would I find that angle in between? So from north out to AB is 13, oh, geez, is 13 degrees. From north out to AC is 40.6 degrees. So what's B, angle BAC? I'll take a sip of water so you guys can unmute and join in. Okay, did everybody fall asleep, pass out? Othello, yes. Thank you. Exactly. It's going to be the difference between our full 40-degree angle and take away our 13-degree angle. And that's going to be our new measurement, 27.136. So that's our first interior angle. That's straightforward. Okay. Just break it down into smaller pieces so that it's more manageable. Next one, let's look at angle B. Okay. Sketch it out. When in doubt, sketch it out. Sorry. All right. So in this case, we're actually straddling that southern line, right? So we have this south-facing line. So our measurement off of that vertical back towards A is our same 13.4647 degrees. Our measurement from our south line out to C is 21.308. Okay, converting that. So how would we find angle ABC? Don't overthink it.
That's nice. Yeah, right. And you would just add.
Absolutely.
It's a lot easier to see than the first one, I guess.
Okay. So that's what we're just trying to find is what are those interior angles? All right. How do you want to go about solving for angle C? How do we want to do that one?
Just add AB and then subtract from 180.
Absolutely. Thank you. Yes. Easy peasy. And I won't even add the lemon squeezy. All right. So those are going to be the kinds of problems you're going to see on your homework. That's what we're going to come up against is how do we break down these angles and figure them out, right? Bearings, they're measured off our north-south lines. Which quadrant do we go into? That's really as what we break it down into. Is do we measure to the right or the east? Do we measure to the west? Are we starting on our south line and measuring west or east? It might be backwards to you guys, but okay. Any questions so far on bearings? Letting it sink in. Okay. Ooh, hey, scrolled right through that. All right. Well, once again, wrapping up a little bit early. I don't think anybody's objecting to that. Exam 1, if you have feedback for me and don't want to share it here, please send me an email, drop me a line. Carrier pigeon is fine. Just let me know what worked, what didn't. If we need to put more time next time, if we need more opportunities to review the questions, please let me know. Thumbs up was or nothing. Thumbs up if it, let's see, how do we want to do this? Was it too hard? Was it too much? Was it over the top? Okay. Okay. So if anybody is looking at what the scores are, can you see those scores? Okay. Do you see what Canvas graded your tests at?
It's like 6 out of 100, and it's marked late also. I don't know why.
Okay. So that's that's part of the problem. Because one of them was basically an essay question, right? The first one you had to fill in your own answer, and we were looking for a couple sentences. There's no way for Canvas to grade that. So I have to go in and look at it and assign points. Do not let the Canvas speed grader automatic grading system influence you. Always wait for me to finish grading them and get them back to you. Okay, and get the results posted so that you can see what your real score is. That speed grader thing is really misleading, especially on stuff like this. Okay. If you don't put in exactly what I have down as the answer, maybe you carried it one digit too far. Maybe you transposed a couple numbers. I can catch that and I can fix that, which I've been doing on the quizzes. All right, same thing is going to happen on this exam. So if you see that you got 20 out of 100 or you got 0 out of 100, don't panic. Okay, let me finish grading them. I will get them back to you and then we can talk about it. Okay. Office hours are going to be Wednesday, 12:30 to 2:30 in the STEM Center. Come find me, come see me. I will sit and go through the homework with you if that's what you want to do. If you want to walk through problems, if you've got questions, if you are bored, I doubt it, but come see me. All right. I get bored. All right. So we will look at adding more time to the next exam. We were supposed to review leveling, but you guys had just finished a quiz on that or an exam on that. I didn't think we needed to beat that horse to death. And we went through horizontal angles today. All right. We talked about bearings and azimuths. We spent a lot of time on bearings. That's what we see a lot of in the industry. What the angles are, what quadrant does that put us in? We need 3 pieces of information to define our direction, right? What's our point of reference? What direction are we going and how far are we going? Okay. So right now, as I sit here and stare at my computer, at my camera mounted on top of my monitor, at my house, I am facing due west. So the sun sets right behind my camera every single day, except for the tilt of the earth, right? So what is our frame of reference? What is our directionality? Where are we looking? Okay. North, south. Bearings are always measured off that north-south axis. Could be a latitude line, could be a, latitude, longitude. There's a reason I went into construction. Okay. So we're always measured off of that vertical in terms of bearings. Azimuth, 360-degree circle. Okay. All right, next class, next Monday. Homework assignment number 4. It is posted, but seriously, that's all it is, right? Chapter 9, problems 3 through 21, only the odd numbers. I don't need you to do all of them. It's good practice, but only the odd ones to submit. And then read chapter 9. That's going to help explain a little bit more about what we talked about tonight and go through that. There was something else I was going to say. Oh, homework assignments. Engineering paper, right? I have my big thick pad of it. I am not knocking anybody. I'm not deducting points if it is not turned in on engineering paper. But after the next homework or so, I will. Get a hold of somehow, some way. You're gonna need it for the rest of your career in engineering. I promise you. Kyle, do you still use it?
No, I do not.
Come on, you're supposed to lie.
I have a solution to using engineering paper. I've engineered a solution because I always was so upset by how expensive it was. So the entire point of engineering paper is that you can photocopy it without all of the lines showing up. So what I did is I printed out a 5x5 piece of paper, and then I just take printer paper and I just lay a piece of printer paper over my 5x5, and I use that for the lines. Yeah, or I also did print off templates. I did have one question / announcement. Does anybody want an office hour tomorrow before your lab book submissions are due? I can do that if anyone wants it, but otherwise, I'll try just to get back to your emails. If you want it, shoot me an email. And I can do an office hour 5 to 6. Otherwise, turn in your labs 6 o'clock tomorrow evening. Thanks, everyone.
All right. Good job tonight, everyone. Thank you for playing the home game. The intent is that the classes are interactive. Share with us, get things wrong, come back, figure out why they're wrong. We'll all grow as a group, okay? All right, everybody, hope Kyle's out of here. He's putting on his backpack, he's leaving.
I'm still at work.
Well, technically, so am I. All right, so everybody have a wonderful evening. I'll get those the homeworks and the exam graded, and we'll go from there.
I tried
Yeah.
uploading a template for the file for the, if that helps.
I saw that. That's great. All right. My keyboard is dead, so I'm gonna hit, I think I stopped recording. If anybody has any questions or anything, please Canvas, email. I posted my email address. Don't hesitate to ask. Don't hesitate to reach out. Okay. With that, have a good evening.